Programming is giving instructions to a computer in a language it understands. And computers, like we learned before, need instructions that are precise, happen in the right order, and cover all kinds of situations the computer might run into. But what really is code and what does it look like? We often think about programming looking like a series of ones and zeros, but there is so much more to code. Odds are you've actually followed or even created code already. Knitting patterns are kind of code. They are in sequence, precise, and can be followed to make exactly the same kind of shirt as the original author was thinking about. All of these things are coding of one type or another, but when we think about coding, we usually think of a sequence of symbols someone types into the computer to solve a problem. So let's look at some code. This here is code in a programming language called Ruby, one of my favorites. And this too is code, programmed with an older language called assembly. Both of these pieces of code actually do the exact same thing. They show the word "Hello World" on the computer screen. But at least in my eyes, the Ruby one looks a little bit friendlier. So why is that? In programming, we have what we call low-level programming languages and high-level programming languages. First, we have assembly, which we call a low-level programming language because it's so very close to the hardware of the computer, which makes it very fast, but also harder to read for humans. If we used assembly to choose the biggest number in a list, this is how much code we would need to write. Ruby, the programming language we saw first, is what we call a high-level language. It means it's a bit friendlier for humans to read and write since other programmers have written thousands of lines of code to hide all the complexities from you. And it would look like this. These packages, libraries, frameworks, and modules mean you don't need to do all the writing. At your fingertips, you have software that can change the color of your website, rotate an image by a number of degrees, or do complex numerical analysis.
JavaScript, C#, Smalltalk, Unity.
So why isn't there one universal programming language? Since software solves so many different kinds of problems in the world, we need many different kinds of programming languages. You wouldn't choose a pipette to study the night sky or use a ruler to measure weight. That's why we need many different kinds of programming languages. It all depends on the kind of problem you're trying to solve. If you want to make a game, you could use Unity or C# or JavaScript. If you want to program a robot, you could use Python. And for teaching, we often use languages like Scratch or Logo. So what happens when someone decides to write a piece of program? They open a text file and write the program with the chosen programming language, which almost resembles English and allows us humans to understand, update, and modify our programs more easily. Then there is a piece of software that compiles this code into a language the computer understands. This is where the ones and zeros come in. This is the machine code that actually runs on a digital device. And finally, after the computer goes through the code and understands what it needs to do, we see the end result. The bad news is you'll need to learn many different programming languages throughout your life. But the good news is learning a new programming language is not as hard as, say, learning Chinese after learning Finnish. All programming languages, they share things in common. All programming languages have the concepts of sequence, which is specifying instructions to happen one after the other. Iteration, which is repeating a set of instructions over and over again. And finally, selection, which is choosing between two different sets of instructions. So let's see if we could create a programming language for dancing that would incorporate all of these. So let's start by defining a sequence of instructions. Clap, clap, stomp, stomp, clap, clap, jump. That was easy, right? Okay, so here's the thing. Programmers are lazy. Loops are one of the coding tools for taking a shortcut. When a programmer sees a pattern that repeats, they can use loops to only write down that pattern once and command the computer to repeat it a specific amount of times. Each repetition is called an iteration or a loop. And now, a new rule. While this color is showing, you repeat the dance sequence. When it's not showing, you can improvise.
Syntax. Arrays. Function.
You might still be thinking, why are there so many different programming languages? And especially why different programming languages, they use such different vocabulary to describe the syntax. That's because computer science is a young discipline. And little in computing has a single reliable name. But these three things, selection, iteration, and sequence, they form the basis of all different programming languages. So what does it mean to learn to code? Well, many things. The same way not everyone who studies music composes a symphony, not everyone who plays ice hockey gets to go to the NHL, or everyone who learns English grammar writes the next great Nobel laureate book. Learning to code is a continuum of things. You can experiment with code, tweak and change it. You can copy existing programs, run and make small changes, or you can write a program entirely from scratch. And syntax, it's only a tiny part of the process. When we think about coding, we often only think about the act of writing the code. But in reality, coding is also the part when you think and structure the problem, and also the part where you fix the problem and the code, because code never works the way you anticipate. Coding, it requires a lot of persistence, creativity, and collaboration.
Dear Linda, how are algorithms and what is data?